Hello, and first of all, welcome for all the people here in the room in our beautiful office in Leuven, and especially to all the people that are visiting us online. We had over 250 subscriptions for our event today from many different countries. So before we start and go into the topic of API security, let's first give a small update on who or what is Solita. Solita is a data-driven consultancy company who creates value out of data in a connected world. Now, what does this mean? It means that we utilize the data that we have available and we combine it with an IT system, because you need the data, you need an IT system, but those two itself, they don't mean anything. We need to assign a value to it. And how do we do that? We assign a value by human insight. We generally add a meaning towards that data. We don't do this alone. We don't create everything ourselves. We work together with technology partners, and we use their software to really add an additional layer on top of that data to create those values. Like I mentioned, we are a European company. We are scattered all over Europe, especially in the Nordics. And from all those 6 countries which we are present in today, at least we have several attendees visiting us online. Now, why are we here today? We are here today to learn more about API security, but before we go into the depths of that, we need to understand where we came from and how did the IT landscape change over time. So the first point in evolution was when we had a monolith application. Remember, back in the days, you had a big mainframe. We refer to it as the dinosaur of IT. They were robust, they were big, but they were not scalable. They were one big application, and over time they become very complex to maintain, especially with people getting older, knowledge fading out, and people did not dare to change that anymore. If we skip then a couple years further, we had the introduction of SOA, a service-oriented architecture. This is where we started to see reusable services, where people really created different layers of governance. You had your technical layer, you had your business layer, you had your gateways. So really, people started to create reusable and smaller components. Of course, at that moment in time, with the introduction of SOA, we also saw that an enterprise service bus was introduced into the landscape. With the introduction of an ESB, it also meant that we had one single point of failure in the IT landscape. So if the ESB went down, there was no availability of any service at that moment in time. Of course, with everything on one big ESB, all the code source became bigger and bigger, and it was also difficult to maintain. A couple years ago, we saw that the introduction of microservices was added, especially to solve all the disadvantages that we had on SOA. Especially if we look at the large code base, microservices, they only had the code, what they needed to have that service, that functionality available. And so they tried to solve the disadvantages, but they also added a different level of complexity, because every microservice developed their own logic and function. And if you had to call another microservice to really get additional functionality, it became difficult to test. It became difficult to debug as well, because you had to call many different services if they were available or not. At that time, we also saw that there was a cultural change. The introduction of agile teams was added because you created small teams which are fully functional, which did everything that they had to do within that team. They created their own logic and they were technology independent. Today, we are only talking about APIs, or a lot about APIs, and we like to refer to this as the layered API era. And this is the time where IT is not the enabler anymore. The enabler is the business. And we really start from a business point of view to create APIs that really add value for an enterprise. Now, with the introduction of APIs, and we saw that the landscape evolved over time, we also had developers in each era of that moment in time. So they evolved from a monolith towards APIs. But the best practices, they also evolved slightly, going from one stage to the other. But they are not fully adapted to that. So we always take in some dependencies and some luggage from the past. And API development is supposed to be fast. And how do they do that? Is to really create code which is returning the functionality in a very fast way, but they also don't worry about what is everything around it. So the developer doesn't worry about what security is needed. They worry about what does my API need to do and how fast can I return the data. And if we then think about if we need to test quickly, we often tend to ignore all the security aspects. So we often test without authentication because it's easier, because otherwise we need to request tokens, we need to have certificates in place. And to test it, it is always easier without security. But then we often, or sometimes we forget about the security policies, and then we go into production without security on top of our APIs. And with that said, if we don't have security, we might have the risks to leak data, which is unintended, or at least have a possibility to harm our company. Because if we have unsecured APIs, it means that people can access data, it means that people can access our systems, and there's a bigger risk into that. And with that said, I would like to introduce Simon. Simon is our senior API practitioner who's making sure that our API offering stays ahead of the curve. And he will teach you today about how we can secure our APIs and how you can detect the pitfalls and what could be possible solutions for that. There you go, Simon. Thank you.
Thank you so much, Jeroen. And also thank you so much, everyone, for being here, people online. It's crazy to me that there are so many people watching. A big thank you to the team for not constantly reminding me about how many people are going to attend, because I would be freaking out right now. Let's take a look at the agenda. First, we'll look at the API landscape today. So where are we right now? We'll take a look at examples of API breaches. So what do they typically look like? It's not what you might think most of the times. We'll take a look at the top 10 threats right now. So this will be very useful because it happens everywhere. And then we'll talk a little bit about API security practices, concepts like the security layers and shift left, shield right. We'll end the presentation with a little bit more about security and API design, as we know out of experience working with different customers with different maturity levels that going API design first can actually benefit you a lot. So I'm happy to be in this room together with you guys and people online because we have one goal in common, that is making great APIs. And we are definitely not alone in this as well. So this slide, and we're not going to go over every company or each technology, but those are the players in this space. They make up the programmable economy. And we see on this slide our beloved vendors, where we have been working together with for over a decade. And we also see, for example, that there are companies that are offering their API as a product right now. I'll take one random example. Payments over through MasterCard, they're all powered by APIs. So a lot of your day-to-day stuff, without even realizing, is being powered by APIs. Now, this is all very good, and it's not hard to imagine that there's actually millions of APIs out there. But one worrying statistic, or two worrying statistics, a recent study showed that 41% of participants in the survey, 41% of those had a security incident related to APIs in the last 12 months, of which 63% noted that the incident involved a data breach or data loss. So that's not good. So this means that there's still, on a wide scale, room for improvement. And maybe we are getting a bit ahead of ourselves, trying to chase the speed and agility of APIs. And we should take a step back and think about security. Before we head into the examples, I just want to say we are not in any way affiliated to any of these companies. And also, this is not about pointing fingers, right? Making mistakes is a natural thing. It's part of life. And we are very lucky that we can learn from the mistakes of others. We even have to learn from our own mistakes, right? So we'll dive into the first example, and maybe by a show of hands, who has ordered something online in the last 6 months? Cool. So this guy did too. And he looks very happy because he doesn't know yet what's about to happen to his data. So when you order something online, you can track your parcel in real time on a track and trace page. What you typically need for this is your parcel number and your zip code. And this is typically secure enough for people to not just guess it, right? But what penetration testers found was that on the tracking page, there was actually a vulnerable API. And that API generated a map image, so that's your map image where your home is, where your package is going to be delivered. And that was not rate limited. So already we see a huge risk, because now attackers can just fire ahead at this API and just ask for random parcel numbers. When they found an image, then of course you use the image to guess the zip code. If I see my street name, I know my zip code. So now I have my parcel number, but I also have the zip code. So what happened next is the attacker gains access to your tracking page. And on top of that, that API also exposed way too much data about you. So for example, your phone number was not displayed on the screen, but the API in the backend, it just gave your phone number. And while it's not visible, you need to understand that it's still there. So this is a concept, excessive data exposure, that we're going to discuss. So the vulnerabilities are here, no rate limiting. You can just fire ahead. You can do millions of requests, and it won't time you out. And excessive information exposure. And here I made a mock response. This all seems very, very logical for a track and trace page. My actual delivery time, this was when it was actually delivered, the order date, dimensions. But here you see at the bottom suddenly notification settings. So what does this actually mean? For this postal service, I said, well, I want to be notified on my phone, right? And so probably I gave my number there, but is it logical that that phone number is returned there? Absolutely not. You wouldn't just display my phone number on the page anyway, so why is it there? Next up is a rather embarrassing one for the developers of a dating app. So a vulnerable API returned the exact distance between you and your potential match. And you might be thinking, well, you can't do anything with that. And if you look at the picture, it's just a dot with a radius, right? So if my potential match is 5 kilometers away from me, that match could be anywhere on that radius, right? You don't know where that person is. And when you look at it in isolation, nothing seems wrong. But then someone just used 2 other devices, and suddenly you have 3 of those dots with each their radius, and on the intersection where the green dot is, there is your potential match. Pretty creepy, right? So you need to think about every field that you're returning in your API. So these guys were probably like, yeah, you can't do anything with that distance, but intruders can go to great lengths to try and break your system, so you need to be aware of that. Vulnerability here is excessive data exposure. And the next one, I'll try to tell the story without incriminating myself, because I found this one myself in the wild. So I'm a very curious guy. I'm interested in music, so I spend my time on a lot of music platforms. So when I arrive on a web platform, I just look at the API calls, right? I'm in the API business. I just wanted to know how they do it. Are they doing it well? And I discovered a few things. First of all, the user ID was an incrementing integer. And when you look at this in isolation, nothing seems wrong, right? I am user 1. When you register, you are user 2, and so on. So I was user 1 million plus. I also noticed that all functionalities on the website were not rate limited. I could just click and do any operation on this platform, and I would never get timed out or get a notification of too many requests. But then I found in the chat functionality of this platform, it actually exposed highly sensitive data of me, my encrypted password, my email address, my phone number, and more. So I was pretty crazy to discover this, and I tested this a few times. So I got the encrypted password of the admin, yeah, and I did the responsible thing. I didn't hack the entire platform. That would be crazy. I sent them an email. Look, my encrypted password is out there. Anyone that has started the chat with me, I should be worried, right? Because if they know this, if they went and looked in their browser to the API requests, then they would have seen all of this, and they could have just extracted it over time. So you hear those stories about people getting handsomely rewarded for bug bounties. Instead of asking for my bank details, they asked for my t-shirt size, and I was rewarded with 1 t-shirt. So maybe a question towards the audience: how much t-shirts would you pay for the integrity of your entire user base? Because when you look at this, the user ID is an incrementing integer. We don't have rate limiting, and we have exposed data. It takes you 10 lines of code to extract the entire user database. I start at user 1, and I end at the last user, and I start a chat with all of them. And that's it. That bug was fixed the next day. all of it. The site was completely rate limited after, and all of those fields were gone. So now we'll have a look at OWASP. OWASP is the Open Web Application Security Project. It's basically a non-profit foundation, and they have one goal: the security of web applications. And this is also the foundation where we get the top 10 lists from. And these lists evolve over time, and they're actually working today on new lists for 2022 of new, maybe more relevant vulnerabilities, as of course the industry is evolving. We're learning new technologies, and also new vulnerabilities emerge. So if you're interested, if you're working on security right now, this is your go-to place to learn anything about technical practices, how to do authentication, authorization, all that stuff. They have made it in a very condensed and very digestible way. We will have a look at their top 10 API security project. So here you have the list of them. We will just go over them, what they are, and just a few pointers how you could start addressing them. Broken object level authorization. I'll just put it in normal language. I'm trying to access an object that I'm not authorized to get, right? So attackers typically, within an API request, they try to substitute IDs in the request because they know, well, my item ID or my object ID is 123. Let me just try 124, right? I know this is not one of mine. Maybe it belongs to someone else, but let me try and access it. And a good security policy would check that actually in the backend and make sure that you cannot access record 124. But the lack of authorization checks allows attacker to just access it. So for an API, this request actually doesn't look suspicious at all, right? It's just your typical request. It doesn't actually know that string doesn't belong to you, that ID doesn't belong to you. So you need to validate this. If you don't do this, then anyone can do anything. So let's give an example. Let's, for example, say that I have an operation, a get operation, which is called financial info, and my company name is company one. I'll try, I know some companies, right? Well, I called it company two for this reason, but I'll just try it. And if that works, that means there's no object level authorization. And it gets even worse when you have IDs like this. And I want to think again about the music platform. If you're using IDs, you're making it very easy for intruders to just write a for loop, right? And just go over the IDs. So I could just try 124. That's what they will typically try. And it is exactly at this point. So the API, the malicious request goes to the API. The API just forwards it because it could be the owner of 124 sending it. But if you don't validate this here and it's okay, then he will get the response back. How do you prevent it? You should implement authorization checks with user policies and hierarchy. This means when you're dealing with APIs, you should know who is calling them and what is their role and what should they be able to do. If I have a user role, I need to make sure, he can access his own record, but not others. He can edit his own record. He can certainly not delete records. Things you need to think about, because there will be maybe different kinds of users. So that's another layer of complexity. And you should not rely on the IDs that the client sends. Maybe use a session object, or just that the request doesn't contain an ID that can be easily modified. And before you go to your database, especially just check if the transaction is authorized. And then the last point, it's a best practice, try using UUIDs instead of IDs. I know it's easy to get an auto increment. It's unique, right? The goal of IDs is that they are unique. But you're opening the door for exploits if those are just auto increments. So maybe a UUID can be better there. Next up, we have broken authentication. As the title suggested, it could simply be unprotected APIs that are considered internal. And this is actually funny because you see it everywhere. You have your internal APIs. These are the APIs that we use, right? And then we have the external APIs, and those are very secure, right? Those are for our partnerships. Those are for external users. But there's actually no such thing as internal, right? All APIs are somewhere on the internet, they're somewhere on a server, and infrastructure, every now and then it gets compromised. So you have no excuse to be less protective or unprotective on your internal APIs. And one should make it a best practice to secure them as well as you would if you would give your internal API to someone outside your company. Would you be comfortable, yes or no? It's a question you should ask yourself. Weak passwords are also a part of this. If you store passwords in plain text or poorly hashed with let's say, outdated encryption algorithms, that they're shared between people, or even worse, default. Default is so easy to exploit. If attackers get a hold of what software you're using, it gets shared everywhere. That default passwords get compromised before you know it. Authentication that is susceptible to brute force. I want you to think about logging into any modern platform right now. If you fail to log in 3 times, it will not let you anymore, right? It will say that's enough now for this amount of minutes. And that's actually because the API behind it is rate limited. It will absolutely block you after 3 tries, and you need to wait a long time. And that is because if your credentials got somewhere in a data leak, they will just try it. They will run a script, and if your authentication is not rate limited, they can literally use any user within that breach without being stopped. And also weak API keys that are not rotated. People that are maybe working with API tokens or JSON web tokens, if you don't let them expire at all, then they might get picked up later. You hear stories about old logs from maybe months ago getting compromised, and within that log you see your bearer token, and the attacker might be, what the hell, I'll just try it, and it still works. So the lack thereof is, of course, also bad. And if you use JSON web tokens, if you don't sign them, then you're defeating the purpose of the JSON web token. So how should you prevent it? Absolutely use rate limiting if you have authentication APIs at all. If you're using authentication frameworks, then this is already built in. But if you're writing this stuff yourself, you need to make sure that it's rate limited so that's not abused by credential stuffing or brute forcing. Lockout policies so that you lock users out that try too much. And weak password checks, absolutely, when you're dealing with basic authentication with user password, make sure that you have enough complexity in your passwords. You should look up for a lowercase 8-digit passwords how long it takes actually to brute force it, and it's not long. And use short-lived access tokens. And you should lean on the giants in the industry. The OAuth 2.0 framework or OpenID Connect are built and maintained by people that actually know the stuff. Don't write this stuff yourself. If you're going to reinvent the wheel, don't do it unless you want to know more about wheels. So I don't think the goal is to learn more about authentication. I think the goal is to have safe APIs. So lean on the giants and maybe contribute. And authenticate your apps so you know who is consuming your API. It's very important. Next up, we have excessive data exposure. We already saw it in almost all of the examples. So I would say this is almost the most frequent one. The API returns the full data objects as they are stored in the backend database. This was very much the case for that music platform, right? Encrypted passwords, are you kidding me? That's just selecting the user table and putting it in the response and sending it back to the browser. Of course, your client application filters the response, but it's still there, right? Because attackers will just call the API directly and get all the data. They're actually not even looking at your page because they know. You see it with your eyes, your page, you would never put an encrypted password on there, right? Maybe it happened once, but I don't know. But they will definitely not look on your page. They will just instantly look at your APIs and see if they contain anything more. How should you prevent it? And that a rule of thumb is never to rely on the client to filter the data. It's that simple. If you have a client application, let's say a web application or a mobile app, and you already have an API that could populate this page, then it would almost be a reflex, yeah, let's just reuse the API, right? So simple, we already made it, just plug it in, we'll filter out the rest. But that's exactly the mistake that they made on that platform. So carefully define the schemas for all the API responses. So We'll talk about API design first in a bit, but do you think those people on the music platform have thought about the API before implementing? I think rather it was implemented before they actually were thinking about the schemas. And if you would show me an API that returned an encrypted password, you could start over. Do not forget about error responses. We'll see a vulnerability specifically for that as well. You don't want people to figure out what software you're running on. That's actually very dangerous. So if you have a stack trace or a default error, maybe just define for your API, now what is my 200 OK response? What should I return when it's unauthorized, when it's a bad request? So make sure you define these and make sure that when you test your API, that these actually conform and that there's no case where suddenly a lot of information about your platform gets relayed to the attacker. And especially when you're dealing with sensitive data or PII, personally identifiable information, you need to justify its use. And that's where perhaps the shipping company should really have to evaluate, is it logical that this phone number is on there, on the API? And the answer is no, of course. You can enforce response checks to prevent accidental leaks of data. So on the way out, you could perhaps do some extra checks there. Also, in many of our cases, there was a lack of resources and rate limiting, where attackers just overload the API by sending more requests than it can handle. So typically, if there's no rate limiting and it can be abused by, let's say, scraping the data, getting all the data of your platform, attackers will typically use it to do that. But of course, if they find a lot of APIs that are not rate limited, they can deny your system of resources, of course. They will just send copious amounts of requests and your server will have a very difficult time dealing with it. So they exceed the rate of API processing, clogging your machine up. But also the size of the requests, and this is very, very underrated. If you already know within your API how big your typical request is and how big your typical response is, then this is actually a very valuable thing. Because anything that would greatly exceed it is actually suspicious. So setting hard limits on the size of your requests or responses can actually help you. But this needs, of course, a little bit more digging. Make sure you explore all the edge cases. So this is then your simplified diagram. I send 1,000 requests, your server catches fire, figuratively. So how could you prevent it? You can define proper rate limiting, and most of modern day API platforms or integration platforms, they offer this out of the box. Limit the payload sizes, and of course, tailor the rate limiting to match what the clients need. And a lot of people that don't do rate limiting, they actually think, well, it might impact the performance of our user. And of course, you should think about those things when you're designing your API. Again, a big reason to do API design first is where will this API be consumed and how many times? And how many times is actually starting to be suspicious? For me, I can mistakenly mistype my password. That's one failed attempt. I can maybe do it twice, but after a third time, okay, maybe that's it's getting a little bit suspicious. So you need to set those boundaries and figure out what legitimate use is and what's non-legitimate use is. You can add checks on compression ratios. Intruders can also try using compression in transit to make it seem that the payload is smaller and it gets decompressed in most standard tools, making, of course, the payload very big. And you need to define limits for, let's say, if you're using container resources, you wouldn't want to auto-scale for someone just blowing the hell out of your API. An example of how this would look in your API design. So when you're designing an API, perhaps you could say, I'm just going to add these headers in already. This is the person that is designing the API, and it's already in there. So when a developer sees this and imports this, he sees, there should be a rate limit header. What should be in here? Maybe he doesn't know. But thinking about this stuff early will definitely reward you, because you have a single source of truth of what should this API do and what are the limitations, and are we figuring out how it can be abused? Number 5 is broken function level authorization, which simplified means they will just try calls to an API endpoint they shouldn't have access to. And they typically don't have this information, but if you're building like a consistent API program, people can start to think, what if I change the get method to put? Will that work? That's a very simple one. But if I, for example, have a endpoint with users in it, can I maybe put admin in front of it? Maybe there's like an API that was tailored specifically for admins. The users, of course, don't know about it, but you can guess, of course. And so this is a very dangerous one if you don't authenticate or secure those APIs. So for example, here I have my first request. I'm just doing an API call on users. I get a list of users, and I'm wondering, maybe there's an API resource that was specifically made for admins. I just try to put admin in front. And if that works, then I'm in. So how do you prevent it? You should not rely on your client to enforce the admin access. And in fact, you should deny all access by default. Only allow the operations that are belonging to the users and have the appropriate permissions. And a very, very underrated one is properly design and test. Well, design your authorization. That's logical, but you need to test it as well. So of course, maybe you're doing acceptance testing and you're just like, okay, we authorized now, we authenticated. We'll just carry on with our happy flow testing, maybe some edge cases, but also try to break it, right? Try to break it and see what comes out. Next up is mass assignment. I think this is a very interesting one because modern tools will often give you ways to develop fast, right? And what this actually means is, it's a very long definition, but say you're sending a request to the backend and it automatically binds all your request values to an internal object, which means there's no mapping in between. It automatically binds. This is very dangerous, and I'll explain this with an example. Let's say I register, this is a very simplified example. I register on a platform. I have my username, date of birth, first name, last name, and email address. I see this because I'm monitoring the requests. Later on the platform, I figure out that there's also, when I go to my profile, I see that it's a get on the user resource, but I see suddenly that there's balance and user type. So I'm learning more about the user object now. So maybe I will try, the next time that I make my account, I will actually modify the request and give myself some cheese and change the user type. So, and if your backend automatically assigns the values, because you learned this, so the user object actually has a parameter called balance and user type, and it doesn't validate this and it automatically binds, then I can typically give myself anything as long as I know about the properties. So how should you prevent it? You should avoid those functions that automatically bind. You should typically know what is coming in from your requests and bind it to your backend or to your database objects manually. You should maybe work with allow lists so that you know which properties can be updated by a client application, and maybe you should also build in to block properties that should absolutely not be updated by clients. And this can be done by defining and enforcing those schemas. And again, I'm going to reference your API specification that you're building in your API design phase. All of this can be accurately defined here. Next up, it's security misconfiguration. And while this is related to APIs, it's just a general common sense that you should not have unpatched systems. If you're doing transport layer security, meaning everything you send over your APIs is being encrypted, so it cannot be eavesdropped, make sure that it's not missing or misconfigured or outdated. Any misconfiguration can actually allow for TLS to be abused, and there's many exploits on TLS that are documented. We already discussed this. Error messages with stack traces. Absolutely don't do this. You're typically using those stack traces to debug yourself. They're actually very useful, but it should never reach the client, because you should have thought about all the error cases and you should offer your client application the correct error messages without them having to worry about your product. And in the wrong hands, for example, they will know that you're running on this technology, and suddenly it opens the door for a lot more exploits, like default passwords, for example, or do whatever, maybe some social engineering even. And unnecessary features enabled. This is a very big one because it's also related to Log4Shell, which was actually a very unnecessary feature that was enabled on the Log4j logging framework that allowed for the exploit to be done. So when you're working with systems, especially when you're installing something and you're just focusing on the task at hand, just know that a lot of systems, there are features enabled and maybe you're not using them. And some features mean opening ports. So check your stack and check your features to make sure that you're not not enabling anything that you're not using. A repeatable hardening and patching process, just so that for each component within your organization that you have, you know when to patch, how to patch, and do it safely. Disable the unnecessary features. And define and enforce all outputs, including errors. And we see that sometimes errors, they get a little less attention because we want to focus on the happy flow. We want to integrate things with each other. So don't forget about them. Then we have injection. So injection has been there for a while, but APIs are just another vector for them, another surface for them. So attackers will just try in your API calls to include SQL, to include NoSQL, LDAP, operating system commands, and just try. And if your backend automatically blindly executes, then you're in big trouble. So consider the following example. I have a get on the user resource. I want to get the user with ID 12358. Okay, this will result in a very unsafe way in select star from users, where user ID is that ID. If I now try this, I do a get request where I do semicolon drop table users. If it will just allow me, it will, of course, first select the user, but then it will drop the user table and all the users are gone. So how should you prevent it? Again, this is a recurring one. In your specification, if you have a field, any string field, you should actually think about sanitization of it. So allowing characters, blocking characters. So you already have well-documented character lists that, for example, combat any type of injection. You need to enforce the definitions at runtime. Modern tools will do that. Another reason to get API first is when your specification is all done and it's all configured, importing that in your system of choice will actually automatically start importing whatever you need to do to make your API, including, of course, those definitions and those string patterns. And you should enforce API output to prevent data leaks. For example, if I would try to get all the users, then this is very suspicious. And typically, this maybe goes back to the example of payload sizes. I know how big my user object is. Typically, I should know how big a name can be, an email address can be, so it will not be 2 megabytes, right? It will just be a couple of bytes or kilobytes. So enforcing that API output check can be very useful there to not accidentally leak more than you should have. Next up is improper asset management. This means that you're not really controlling, you have no clear view of what API is still live. Maybe your production and acceptance testing environment are on the same machine or on the same environment. And they will try to attack those APIs. For example, if you have in your URL v1 user, maybe they will try v2, or the other way around. If there's a v2, they will try to hit the v1. And it happens all the time, of course. Versioning is a big part of managing APIs. But if you don't have the proper catalog management, meaning you should know what you have, you should know what is live, and you should know who is consuming what, right? But also, you should decommission what's no longer being used. So a big part about versioning is also decommissioning. It's telling your consumers, we are going to the new version. Okay, we'll give some consumers a little bit more time on v1, but this is when we stop with v1 and we move to v2, and that API gets disconnected. Because what they call this in the industry is zombie APIs. It's an API without consumers that's still out there, right? It's everyone switched, but it's not decommissioned yet. Common best practice is to keep your prod and non-prod separated. And the last one, and I think this is complementary with all of the vulnerabilities that we've seen today, is that if you do not log or monitor your APIs, People can do anything, and you won't have the slightest idea what's going wrong, and that's very dangerous. So malicious API attempts, they fly under the radar. An interesting statistic from some years ago was that it took about, on average, 162 days for an API breach to be discovered. So that says a lot about how things were logged back then, and maybe give you something to think about. What are we logging today about our APIs? Are they properly designed? So typically, if the logs and alerts are poorly designed, you cannot make sense of it. Especially when it's non-automated and there needs to be a person that has a look at those logs to figure it out, then it gets really dangerous. How should you prevent it? You should definitely log any failed attempt, denied access, for example, input validation failures. So if we were very secure, and for example, we did input validation so that I cannot give myself money, right? Then you should have a very clear error. Someone tried using your client to create a user and give himself balance, right? So anything that's out of the ordinary, failing validation in a very strange way, you should log it and you make sure that you get an alert for it. And you should include enough detail in the log to identify the attacker, but I think that would be horrible to see the very thing going on that's intruding you, and you cannot put a user on it or put identity on it. And you can leverage modern monitoring and alerting tools for greater visibility. So these were the top 10, and when you're dealing with API security, it's not just checking the boxes. This vulnerability, we need to do this. This vulnerability, we need to do this. And what we have learned working with customers over different maturity levels is that we always see the same layers emerge. And these layers are just abstractions of API security where you can ask yourself a very specific question. And tackling that layer will, of course, help your API security posture. For example, layer 1 API inventory is a very, very key part of it. And a question you should ask yourself is, are we keeping track of what we own? And of course, do all APIs have clear ownership? When an API is made and it's tested and it's in production, there should still someone be responsible for that API. Especially when you're trying to scale, there shouldn't be an API that's unmaintainable by your team. API design, a very big part of it. Are you doing API design first, or are you first building your APIs and generating the documentation afterwards? And are you incorporating security in the design? I already showed you a few examples on how you can incorporate the security in your design. So are you doing it? API development and testing. Are you trained properly on your software stack to properly write and test secure code? Not only that, but are there procedures in your organization to build this knowledge? For example, you are onboarding a new API developer. Does this person have the tools to learn how to properly write it in your software stack? It's very important. And is there threat and risk awareness? I hope after this presentation there's a little bit more, but of course this is something that you'll have to maintain over time. API protection. Are you using protection technologies? For example, most API gateways offer this out of the box. Policy enforcement, token validation, anything you name it. Are you using it right now? Web application firewalls are also a big part of web communication, of course. And then at the bottom, API governance. Are you actively controlling your whole API strategy? And are you making sure that it's still aligning with the business objectives? And why I'm telling this is, it's ultimately the business that will give you the funds to power your API program. And you need to continuously show this value so that you secure the funding to build out more APIs and to, of course, properly secure APIs. So these are the layers where you can make different layers of abstraction of layers of API security. There's no single way to go forward, so you can think about a lot of things. Next is a concept that, now it's still an empty slide, but it's called shift left, shield right. And basically what this means, if you have your software development lifecycle, you would typically begin with your design. And what we mean with shift left is that we are shifting the responsibility of security to the left in the software development lifecycle, where typically maybe this only happened right before testing. This should very much be something that you should be doing in the design phase. So you write complete API specifications with security attributes in them. And you're doing API design reviews. You could do something like API specification linting. For those of you that don't know it, I have a slide about it. I will explain what it is. It can definitely help you if you're already running at scale. And threat modeling, which is a technique that I'll also explain later in the presentation, how you should think about threats when modeling your APIs. Then you have your development stage, where you, of course, use your safe development practices. You're dealing with threat awareness, and of course, you're managing your secrets and all what's related to safe development. Then you test, and you try to do automated testing if you can, if that's possible. Also, a very important one is the abuse case testing. And when you're doing threat modeling, normally before you have completed your design, you know your use case, but you also know your abuse case. How can this API be abused? And then you test that in the testing phase as well. Authentication and authorization testing, of course, very important. And then on the right, you have deploy. That's what we mean with shield right. Then you actively apply security policies at runtime in production. So shift left, shield right. Now, security and API design. It's very important because this way, of course, you spot the risks early. Why? Because before you wrote one line of code, you already thought about things. How maybe rate limiting can help, how maybe limiting a few parameters in your API can help, how maybe using UUIDs instead of incrementing integers can help. So API design first is the way to spot risk early. And you should leverage the power of the specification standards that there are today, like Open API Specification Standard, or Swagger as it was used to be called, or a Sync API for your asynchronous APIs. In this stage, you can also start to justify the use of your personally identifiable information. Like, does it make sense to put a phone number in here? Does it make sense to put the name in here? These things you should check off in the design. And when you're done, you could maybe audit your specification by using linters. Next up is threat modeling, and just basic simple concept. It's how and it's been around before software development was there, and it's a simple process. You assess the scope. In this case, the scope is your API. You identify what can go wrong. The abuse cases, you need to think like a hacker to become one, or the other way around. Or to spot a hacker, you need to think like one. Yeah. So I identify what can go wrong, define the abuse cases, and then, of course, what are you going to do about it? So you learned a bit how you can countermeasure it. But of course, if things still go wrong, do you have a procedure ready, a remediation procedure ready for this API? Let's say it gets compromised anyway. Did you already think about it? Because this is not something you want to think about when it's compromised. And afterwards, of course, assess for your work. How well did we do it, right? And this should be a continuous process. You learn it with your first API, and you learn what works best, and experience will teach you that. A model for defining risk would have 3 pillars. For example, what is the impact that will result from the if their API is compromised? What is the possibility that we can mitigate it? And how easy is it to exploit? So if we apply this example to the music platform, the impact is huge because we're dealing with user objects, right? The damage potential is insane. The mitigation, okay, it's probably easy to fix. How easy is it to exploit it? You just need a browser and some curiosity. So for some APIs, the ease of exploitation will be quite harder, right? Maybe it's not a public API, maybe it's something that's machine to machine within your organization, but you should also think about it regardless. The next up is linting for security. And what we see, especially in organizations, customers of ours that are a little bit more mature in their API program, they have a lot of APIs, right? And what a linter is, it's basically a piece of technology that developers have used for years that checks for stylistic and semantic errors in their code. It's actually very easy for someone that's writing code to get feedback from the linter saying, well, this is not looking quite correct. Maybe you should change it to this. That actually also exists for API specifications. And one of them, just one of the linters, there's many, is Stoplight Spectral. That's open source, so it's completely free. You can just run it on your computer. And you can actually take a rule set that's directly applied on OWASP API Top 10. So everything we discussed today is actually in a rule set that you can just fire ahead at your API specification. That's very nice. And you should not just blindly rely on it. You can validate your specifications at scale, but this is actually meant to facilitate the API design review. So if you're building a lot of APIs, you're building a lot of specifications, you don't want to do the manual work of checking, is this camel case? Are we using rate limiting, stuff like that? So a linter can already give you a bird's eye view, what could be wrong with your API, because of course this is open for interpretation. In maybe a later scale, you could include this in your CI/CD pipeline, meaning if someone wants to publish this to the version control, maybe you could run the linter, and if it has any critical errors, you say, no, this is wrong with it, and you need to fix it before we can go on with it. And this can ensure that all of your specifications are following the same rules. It's not just that rule set. There's actually a lot of rule sets that can, for example, check if all your values are camel case, and lots of other things. So how a typical output would look like is I ran this on a random specification, and it says that I'm missing the error responses 400, 492, and 500 for my upload operation. Also, it's giving me an error that I should consider rate limiting for my upload operation. It's already very valuable. The headers were not there. And some operations are actually do not have any security scheme at all. So you would take this into your API design review, and you would go over these points and evaluate them. So is it actually correct that we're missing the responses there? Probably not. We need to add them. Should it have rate limiting? Open for discussion. Maybe it's not relevant, but it will regardless give you that feedback, and that's very, very nice. Now, a question that I find very nice is, so where do we actually start? Maybe you should start with your security assessment. Get an idea of how your security posture is looking like today. And the layers of API security can help you with that. Because you can start to decompose the problem and maybe think about, are we dealing with our inventory correctly? Like, do we know what we have? Do we have clear ownership? Do our developers have the correct tools to go forward and make secure code? So you can definitely start there. And explore your current tool set by maybe aligning the top 10 OWASP vulnerabilities and see if you have the tools in your tool set to solve them. Maybe you can start adopting threat modeling and linting as we just explained. If you want to know more about the project API security in particular, here's the link. Very good resource. And with that, a little bit more resources. So here's the, again, cheat sheet series for those of you that want very concise, easy to consume documentation about a lot of security concepts. Very good link for you. And with that, I give the floor back to you guys. If you guys have questions for me, go ahead.
Thank you, Simon. A lot of interesting information and some good tips. Maybe first of all, the session was recorded. It will be available for you guys as of tomorrow. You will all get a download link via email. Are there maybe some questions from the room? Somebody here has a question. We do have some questions online. So I'll maybe start with one from sure. The audience online. A question from Danny. How often do you recommend to rotate API keys for a normal sensitive API?
Typically, a short-lived one would be if you have an operation that would require me to generate a token, and then afterward nothing else happens, then you should really first evaluate how long is my operation typically lasting, right? If it only lasts a few milliseconds, I would argue that your key should not last longer than 5 seconds, because there is no real use in keeping the key when your transaction is done. So it's a bit of a balance, knowing how long your processing time is. And of course, if you have a retry mechanism, then you also need to keep that in mind. Do you make a new token, or do you reuse your current token within your thread, for example?
Okay. If there are questions, please raise your hand. I will bring you the mic. There's a question from Akash. What is a short-lived access token?
Short-lived access token is basically a token that will live only the transactional length of an API call, meaning there is no reuse of the token after the processing has completed.
An additional question, if your API has consumers that use a parallel setup, for example, many simultaneous requests at the same authentication, how would you recommend applying rate limiting to the API?
Typically, rate limiting, you should be able in your rate limiting to distinguish consuming applications at one time. So it could maybe be that you're having multiple requests on your authentication, but I don't think you're authenticating the same specific application multiple times. That would not make sense. So your rate limiting should actually also consider who your consuming application is that is doing the authentication request.
Okay. There's a question to open up the authorization topic. For example, how user, clients, and services or service-to-service communication can be authorized.
Using authorization frameworks like OAuth 2.0 is a very common one to do it. And you can work with, of course, the scopes where you give your users, if you have your policies aligned, you can assign scopes to your API to make sure you have a scope, for example, you can write on the user. That's a scope user write. And you start defining these scopes for your API, and you're using the OAuth 2 framework to enforce those authorizations of your API calls.
There's a follow-up question on the token expiry. Do you mean that each API will need a refresh token?
That depends on your setup. I don't think your API needs a refresh token if it's just a single transaction. Short-lived means your expiry time will be very short. And if you don't need a refresh token in your use case, then by all means don't use it. It all depends on what setup you're trying to achieve.
Okay. So far, those were the questions online. Do we have some questions in the room? Somebody? No? There is one.
Yeah, so most of the things and the problems you mentioned can be solved by doing design first. But many, for example, in our company, we have we have a team who is used to do code first, and they have their build and deploy pipelines generating actually the open API specifications files. And what are your tips on like getting those specifications also up to standards? Because one developer changes something, generates the open API file. How do you deal and to get the cultures aligned?
Yeah,
because it's not always possible to just go design first.
Of course. But the first step, of course, is to have that conversation with that team and to, of course, address the limitations that we now have currently. Maybe the code first is actually being implemented in such a way that the specification is actually also secure. But is that the case or not? So maybe have that conversation first. And also, when you're doing API first, you can show them the value of it as well. And of course, going API design first is a cultural change, and not all teams will blindly follow it. So it will leave some gaps. I think if you're doing way more on your implementation that your specification can hold by generating it, then you have some gaps in reality. And if you need someone to look at that API in a bird's eye view, someone non-technical maybe, they will look at the specification, and it's like, yeah, there's no rate limiting on it, but maybe in the implementation there is. So maybe you need to address, are there currently security policies on these APIs that are being applied without that they're present in the specification? Maybe that's a good conversation starter for that team.
Any other question from the room? No, I don't see a follow-up question online. Then I think we can close the crash course here. If there are any additional questions later on, please reach out to us. And I think we wish you a secure journey on your APIs ahead of us. So have a nice day.
Thank you, everyone.